Takes a lot of reverses, man.
Are your unit tests running very slow? And don't you wish there was an easy solution sometimes to fix them? Jupyter has a solution for that, where you can launch your tests in parallel. And we are going to have a look at that in this video. So unit tests are launched with many different ways. We can launch it with different kind of frameworks. And the frameworks we are looking at today is the JUnit framework, the new version. Well, now it's not that new anymore, but it is the Jupyter version. So we are looking at JUnit Jupyter for our tests. And we are launching our tests in parallel, and we are now looking at ways to launch our tests in parallel. There are two aspects of launching tests in parallel. One of them is how many tests do we want to launch that belong to the same class in parallel? And the other aspect of it is how can we launch different tests that belong to different classes in parallel as well? And there is another concept, and that concept is the idea of launching multiple virtual machines so that we can launch our tests separately. Then they become completely isolated from each other, and that means that we have better control about changes, and we also avoid polluting our environment with different aspects of the different tests, different side effects, and we can make our tests better isolated. So there are two major important topics, if you will. One of them is launching tests concurrently in the same class, and the other one is launching them in different classes. Different classes is for forks, and different tests is for concurrency, or for launching the unit tests concurrently. Okay, this might sound a bit complicated, but we can understand this better if we have a look at one example, and that's exactly what I have. The example that we are looking at is library books. This is one of the repositories that sits under my handler in GitHub, j-esperancinha, you probably know that already, and it's called Library Books. Library Books has projects that have been developed in Kotlin and in Java, and let me just highlight a few of them for you. We've got this back in Java, which is a project that I want to continue developing, which is something similar to what I've developed here. This is simply an application that will talk to the Google API for books, and it will look for books in that API. It's an interesting project. If you want to have a look at it, then please do so. Be my guest. Then I've got these three projects that I have created specifically for this video. This one is a simple project in Ktor. There's very little developed in Ktor. What I have there already are the basics for unit tests, and where I have implemented different examples where we can have a look at how can we launch tests concurrently. Then I've got fork gradle and fork maven. They all have the same prefix, backend service ktor, and then the suffix is either fork gradle or fork maven. The fork gradle and fork maven are just two different ways of doing exactly the same thing, and that is to fork our Java virtual machine. If you don't know this, then let me just say right off the bat, before we continue to investigate how to run tests concurrently, that the Java virtual machine can be forked into different Java virtual machines. Essentially, when we run unit tests, we can spawn different virtual machines that can run the tests isolated from each other, as I mentioned before. So, before we get to forks, it's important for us to understand what Jupyter offers to us right out of the box. So let's see how that works. If I open the project, we will find in the source this main, which has a very simple implementation of a ktor service with a simple getter over here, and then it just responds, hello, it's me. This is not important because our tests, the one that we are having a look at, they implement their own test applications that will do exactly the same thing. But the important bit are the tests and the build gradle file. So let's have a look first at the build gradle file. There's nothing too special over here if you are used to Gradle, but I will explain this very quickly how the structure of the code is made. We've got here the usage of the Kotlin plugin. This is for us to be able to interpret Kotlin code. Then we are saying that our repository is Maven Central. Then we are establishing a dependency that is not necessary for us. Let me just clean this one out. Because we are using Jupyter tests, and so we are not using the code-test framework or the Kotlin test framework. We are just simply using Jupyter. And we've got here now the different libraries that are necessary for us to be able to launch Ktor services, the one specifically that we are going to use for our Jupyter tests, and then we've got the necessary libraries to be able to launch Jupyter in our project. This is not anything new. These libraries are common for different projects using Jupyter. The important bit is, and this is where we are going to start, is checking here resources where we've got this file junit-platform-properties, and here we've got different properties that we have configured so that we are able to launch tests concurrently. It's important for us to understand first that junit-jupiter does not launches tests in parallel by default. So by default, everything here is akin to having same thread. I will explain that later, but what we've got over here is we first activate the parallelization of junit-jupiter tests. This allows then to specify which mode do we want for the individual tests, if we want the test to run concurrently or if we want them to run on the same thread. And here we specify that by default, if we don't use anything else in our tests, that those tests will run concurrently. In this third line, we are saying that when we are launching the different classes of different tests, so we've got one class here, one class here, one class here, for example, 3 classes, and we want to launch the 3 classes in parallel, regardless of the individual tests are being run in parallel or on the same thread, they will run on different threads, the different classes, not the unit test specifically. The combination of these two allows for the tests to run in a parallel way through the classes and through the different tests inside those test classes. All right, then the last 2 lines, line 4 and 5th, these lines configure our tests to run in a certain way where they are limited. In this case, I've got a configuration strategy fixed where I'm saying that the maximum parallelism is 4. And this means that, for example, if I've got 5 tests in one single class and I want them all to run in parallel with this limitation, 4 tests will need to run concurrently, but the 5th test will have to wait until one position is available in that queue. All right, so this is very simple. We can now look at our tests. We are having a look at 3 different examples. The first one is main test, the second one is main test 2, and then main test 3, of course. Now, for the first main test, we can see that we've got a simple implementation of different tests. I'm always calling this test app. It creates a simple service that will return just a hello, it's me response to the endpoint hello get. And what every single test here does is simply call test application, and then they will all do exactly the same thing. In this case, it's literally a copy paste from here and here. So they all have exactly the same thing. If you prefer, we can just simply refactor this. It's not really important, but perhaps we can just call this common test and make sure that we've got the same common test in the 2 tests. Maybe it's easier to understand this way. All right, so what I've got here in this test specifically is that I have annotated these 2 different tests with execution mode same thread. If we go inside same thread, we will see that we've got 2 different execution modes possible. We just download the source, and we see here that we'll force execution in the same thread as the parent node, and the other one, concurrent, will say allow concurrent execution with any other node. In other words, roughly will mean that same thread will not run in parallel and concurrent will run parallel, because same thread means that they will all run sequentially on the same thread, and concurrent means that they will concur so that they can run parallel if there are threads available. So if we go back to this test is now configured in a way that all of the different tests will now run on the same thread, but we have configured them to run in parallel. So what do you think will happen when we run these tests? They will run on the same thread. And we can see that if we run this test, we should be able to see now that it first runs test hello endpoint 1, and then it will run test hello endpoint 2. And if we look at what these tests are doing, is simply each one of them is creating an application, and then it is calling these assertions just to check if the response is hello, it's me, and then finally it will just wait 5 seconds so that we can see the effects of parallelization or not. Okay, so this first test didn't brought us anything new. This is just how tests run normally, and there isn't anything different here. The difference now we will see here on the next test, and that is main test 2, where first we are implicitly saying for the same kind of tests, which by the way I've also copy pasted. Let me just fix that for one moment. So just do this, and then here let's say that these are common. These lines are a common test for both of the different tests. That should have worked. Right, so now we've got the application test 2 with 2 different tests. Right over here we can see that both of them are explicitly concurrent. And if we run this test now, and we are saying that each individual test lasts 5 seconds, then the total of it should take, if it's concurrent, they run at the same time, so it should be also around 5 seconds. Let's see if that's what happens. If I run this, we will see an interesting phenomenon. We see that the tests are running exactly at the same time, and we also see that each one of them took 5 seconds. IntelliJ does something strange here. It will count all the different times of the different unit tests. It doesn't take into consideration that they ran in parallel. So we can safely say that these tests took 5 seconds, and this sum is not correct. Anyways, we can see now that they are concurrent. But are they concurrent because we put here explicitly the annotation concurrent? Was this mandatory, or can we run these tests without these annotations? As we have seen before, that was the default behavior. That's what we mentioned in this file over here. We configured our tests to run concurrently for the tests and for the classes that hold the tests. So let me go back to here, and here we are going to take these 2 away and try to run the tests in the same way. So these tests should now take 5 seconds. Let's see if that's true. They are already running in parallel, and we can see already that this took 5 seconds. Again, the sum is wrong, but we've got a around 5 second time span for these tests to run, these 2 different tests. All right, so now we know with JUnit-Jupiter how to run the tests in parallel. We understand what it is to run concurrently, and we understand what it is to run on the same thread, as we have seen here in the main test, where we explicitly said that we want these tests to run on the same thread. But test 3 is a bit different, and test 3 is going to test the last 2 lines that we have configured for our unit tests. This one has a lot of different tests. It has 5 different tests that do exactly the same. Let me just refactor this and just call this common test. Again, for the other 3, and let's replace the occurrences for all of them. And now we've got, we missed this one because probably it's slightly different, maybe a comma or something, but it's not relevant for this test. And this is formatted. All right, so we've got now all of these tests that are running concurrently. We now know that this is not necessary, so we can just remove all of these very quickly. Okay, so these tests will run concurrently in parallel, and we will also see something different with this one. Now we know that if we run this in parallel, it will take 5 seconds. That's nothing new, but we have 5 different tests, and we have configured in JUnit platform properties that the test should only allow up to 4 different parallel tests. We've got the strategy, the configuration strategy to be fixed, and the configuration is fixed to a parallelism of 4. There is a dynamic configuration, but that one I want to talk about in the next video. For this video, I want us to focus on the simple things about parallelism with JUnit in Jupyter, and we're also going to talk about forks. So let's keep it simple for now for this video. If we run this now, we can infer already how long this test will take. If we take into account that we are launching 4 different tests that are launching in parallel, and the other one needs to wait because the parallelism is 4, the 4 first tests will take 5 seconds, and the next test will take 5 seconds. That means that in total, these tests should take 10 seconds. Let's see what happens. If I run it now, this will be application test 3. If I run this, we should now see that it will take 10 seconds. But see, look at this. It started running the 4 first tests, and now it's running the last one. This last one took 5 seconds. These other 4 took also 5 seconds. So we've got 5, we've got 10 seconds total of runtime for the whole application test 3. So what we've learned now for the JUnit platform is that we can launch tests or classes concurrently. But an important aspect of this is that we launch all of these tests on the same Java virtual machine. And that sounds perhaps strange that I say this, because we always run our tests and our executable files on a JVM, but we need to emphasize that now, because now what we are going to look is at forking. What does it mean to fork a JVM? And what does it mean to configure forking? So the first thing I want to show is how do we do that with a Maven project. And the reason why I'm going to Maven projects has partially to do with my personal preference to Gradle, and it has to do with also the fact that I also like to use Maven, but I like to learn both of them. Although I do have a special preference for Gradle because I see that Gradle has a potential of allowing different kinds of configurations that would otherwise with Maven perhaps be a bit more complicated. But it is also true that the things that Gradle provides aren't usually that necessary for server-side development. So take your pick, choose what you want. But for now, let's have a look at Maven and see what it has to offer. Now, Maven allows us to configure forking of the JVM in a special plugin that you may have seen before, which is called the maven-surefire-plugin. This plugin is mostly used, and somehow it's used just because it works, to kickstart our tests. It is advised to use this many times because without maven-surefire-plugin, sometimes, depending on our configuration, depending on what kind of framework we are using, or even the name of the files that we are using for tests, our runtime may not detect the tests themselves. And so this is something that Maven-Surefire plugin, but this is just one small aspect of the Maven-Surefire plugin. Another thing that it does is allows to fork the JVM, as I mentioned before. Now, here what we are doing is saying simply that I want to be able to create up to 4 different JVMs, and I want to use those 4 JVMs for my tests. Plus, I do not want to reuse the forks that I create. So that means one JVM gets destroyed, a new one gets created. The idea here by doing this is that when we are launching the different tests and we pollute our memory, or we are depending on variables in our code, or you must have gone through this before, that we maybe have a cache or anything that it's changed, and where our tests are depending on pieces of code that have side effects to them, that we don't get the exact results that we are expecting. So therefore, if we don't need to reuse forks, then we should put reuse forks to false. But for our understanding on how this works, we also need to know what our code is doing. Now, our code here doesn't do anything. At this point, it simply just does what by default IntelliJ creates for us. But what's important here is to see our tests. And our tests have got different implementations of our tests. And what I've got here in test 3 is the same as what I have in test 4. I've called this application 3 test and application 4 test because with Maven, our tests will only be detected via the maven-surefire plugin if they are appended with test at the end. Otherwise, we need to have a manual configuration for the tests as well, and I don't want to add that confusion to our tests. So that's why I've got here application 4 test and why I have here application 3 test. All right, but they do the same. They call the same method for every single one of the tests. It calls this method 6 times. This is the application builder common test. It does the same as before, except that here I'm just doing test application and I'm calling the content of the body. And before we called the whole thing in a common test method. It's just the same thing. But what we are doing now is by launching this 6 times, we are also launching 6 different tests. But now we are doing this 2 times in 2 different classes. And this is where forks will work. Because one thing that is important for us to understand now is that forking only works if there are multiple classes, not for multiple tests. As I mentioned in the beginning of the video, multiple tests are for junit-jupiter, perhaps other framework that also provides some kind of parallelism. But forks, that's something that's part of the JVM world. And at that point, we are no longer thinking in code, but actually the way the JVM works and how do we start and spawn different JVMs. All right, so if we run these tests right now with simply just calling maven install, it will do something interesting. But before I do that, we need to know what this common test actually is doing. If we go inside of it, we can see that we've got fairly easy to understand code. We are creating a client here. We are waiting 5 seconds after we get the response and make our assertion to the application that is running on the test environment. But before, that's where the trick is. We are logging the current thread. Then we log the identity hash code. This isn't too relevant for now. But what is very relevant is the process ID. This process ID is what will define if we are spawning or not spawning different JVMs. Let's launch this now and see the logs and understand what these 2 log lines mean. And again, let me just say, print line for logs is not a good thing. It's a great thing for tests, but not for production code. Having that out of the way, let's just go to the command line and run this. So in our command line, I am right now in the backend service ktor fork maven. And now what I will do is run maven install. Or let me just run maven clean install. And now we will be able to examine the logs and see what is happening to process IDs and what is happening to these tests that are being run. I didn't configure junit-jupiter here, so by default they are all running on the same thread. But between the different classes, something else is happening now with regards to forking. We can see that we've got this, and these. These are all logs that are telling us that there are different tests that are running on different process IDs. Now, if I select one of these and I search for it, how many process IDs do you think there will be here? Now, we know that are running 6 different tests in each of the classes. So if we look for one of these process IDs, we should get 12 or 6. 6, right? Let's see it. There, we've got 6 of them. And if I run this one on that find window, then we should have 6. So now we've got 6 different tests in one single class that ran in one Java virtual machine, and 6 different tests in another class that ran on another Java virtual machine. Now picture this. We were able to launch these 2 tests in parallel in 2 different virtual machines, but we still cannot do anything in regards to the individual tests that are running in each individual classes. I could go to this project and immediately go over here to tests, and here create a resources folder and add that JUnit file that we have seen before in this project, which is called junit-platform-properties. And if I would do that, then we would have an advantage. And the advantage is that we would be able to control forking, and every time in that Java virtual machine that 2 different classes would run, we need to think that if we have many classes, then forking alone will not guarantee that one class will run in one fork and the other class will run in the other fork. Actually, that is something that escapes our control. It means that we can mitigate problems like code pollution, as I mentioned before, or resources pollution, but it doesn't mean that we are avoiding them completely. With that configuration, all of those classes would be able to run concurrently as well inside the same virtual machine. But I don't want to touch the Maven example, because the Maven example, I want to keep it static as a pre-step for us to understand what we can do next. And the next example I have is in Gradle. And if we go here to the Gradle project, and this is the last example of this video, we will find that I've got here the build gradle.kts file where I am configuring this. And this over here is a detailed configuration of the JUnit platform, or a JUnit or a unit platform in general. It is configuring all tasks with type test class, and here we can do a lot of things. The first thing we do is say that our platform is JUnit. Then we are configuring a maximum of 4 forks. This means a maximum of 4 different Java virtual machines. And we are saying also that for every single class, we will launch a fork, and that fork will only launch that class as a test. Then we've got other things that are related to login that are also important for us to understand what it is doing. The source code for the test package is exactly the same. So here, nothing has changed. We can have a quick look through it. We can see that we've got the same test exactly the same way. We are also getting our process ID from the management factory get runtime mxbean. The same thing. And what this will do, this will allow us to run the test in the same way as you have seen before for the Maven project. The difference is that now I'm adding in this project as well the JUnit platform properties with this configuration. I'm just saying in this configuration that parallelism is enabled and that by default I am using concurrency. I can also do one thing that I did before, which was, if you remember from the first project we saw, I can say that I also want parallelism for classes. So if I add this one here, I will get parallelism for classes, parallelism for tests, and I will also fork this. If we go now to the command line, we will be able to run this test. Now, I already have a makefile that will make our lives a bit more easy, and this one has the run command for the Gradle wrapper, and it will build, it will test, and it will test with these different properties. One is the no daemon, so that we don't need to rely on caches, and to launch this as a daemon or a daemon. We want to launch our tests in parallel, we want to log info, and we want to rerun tasks if the tests have already run once. So if I run make on this, This command will run and we will investigate the logs. Let's see what happens. So now it has compiled. It's now running the tests. If you have seen before, all the tasks have already started for the different tests. Now the build has been successful. The tests just ran. Now let's just have a look at what the logs say. Let's go further up. Let's see. Here, we can see that gradle test executor 2.1.3.4.1.2, basically 1, 2, 3, have started executing tasks. 4 also. Let's see what this means. We've got 2 different classes. Those 2 different classes will have gradle test executors associated to the virtual machine that they are assigned to. So what we've got here is an indication that perhaps there are 2 different executors per virtual machine. Now this is something that we don't necessarily control. If we check on the gradle properties here, we can see that we've got a maximum amount of workers configured. We are saying that parallelism is activated for gradle, and this is just related to forking. And if we go here to our build, we see that we are using a maximum of 4 parallel forks, and that for every single class we are creating a new fork. So nowhere we are specifying 2 different gradle executors. This is something different that is more related with how gradle works. But what's important for us here is that if we go to the logs further down the logs, we will see that these different 6 unit tests ran on the same process ID. But if we go further down, we've got these different unit tests that ran on a different process ID, meaning that we've got 2 different JVMs running. We also see that the tests ran fairly quicker than the test with Maven, and that is because the test with Maven did not have the junit-jupiter-platform file in them, and this one does. So the tests ran much quicker. We are talking about 6 tests where each different test runs during 5 seconds, running in parallel with other 6 tests of the same format in different Java virtual machines. What is the catch? What is the pitfall of running with forks? The pitfall is that we are launching 2 different Java virtual machines, and of course that can be very heavy in a world today where resources cost money and can have a financial impact in your organization or your personal work. So you have to make a balanced and informed decision about what do you need to run your tests, because you need to measure the pros and cons of adding this to your framework. Nonetheless, if the tests are well controlled and if you are sure to be able to control the resources that the unit tests use, then using parallelism with just JUnit-Jupyter is something that is completely separate from a discussion about resources and using resources like memory or CPUs. In any case, those discussions are important when we are launching parallel tests. Alright everyone, this was the video about parallelism, about JUnit and about Jupyter, a simple approach and a simple start to how to make your tests run in parallel using parallelism in the same Java virtual machine and also using forks. The examples are located in this repository in library books under my handle j.esperancina on GitHub. And I hope this was informative to you. If you didn't know about parallelism with JUnit and JUnit-Jupyter, I hope this video was informative to you and that with this video you are able to expand your horizons when it comes to making development with unit tests and making sure that your tests have good coverage without using too many resources. And if you do have resources to separate and launch with different virtual machines, or if you are thinking about doing that, make sure to make a wise decision, because not always is a good decision to use different virtual machines because they can be very heavy. This is something that I can explore in a video in more detail, maybe not the coming video, maybe the video after that, maybe sometime soon. I will investigate more in detail what are the effects of using all of this stuff that we spoke very briefly in this video about launching tests in parallel. I hope this video was useful for you. I hope you've enjoyed the video. I hope you found it informative. And if you did find the video informative or you enjoyed the video in any way, please make sure to give me a like in this video. Make sure to give me a comment about how your experience was watching this video. Make sure to read the description of the video because it is very important. There I will put all the different information related with this project, all possible information that I have at the moment about how I developed this and what resources I've used and where can you find more resources about this, namely the resources that I will list in this repository. Make sure to subscribe to this channel. There is always a new video coming in every Wednesday and Sundays. Make sure to activate those notifications so that you don't miss out every single post that I make in this channel. And until the next video, be sure to stay tech, keep programming, be kind, and have a good one. Bye.
As a short disclaimer, I'd like to mention that I'm not associated or affiliated with any of the brands eventually shown, displayed, or mentioned in this video.